Hello everyone and welcome to your partner in education, Agile Rank Mate. Today, in this episode of AEEE training, we're going to be looking at some sample questions with their solutions that we can use to study for the AEEE exam. We're going to be looking at questions from physics, chemistry, and mathematics that are similar to those asked in the AEEE exam. So let's start off with our first question. This one is from physics. Addition of a minute quantity of phosphorus to a silicon crystal makes it an N-type semiconductor, a bad conductor, a good conductor, a P-type semiconductor. So, let's look at the question. First of all, we are asked to add phosphorus to a silicon crystal. Now, silicon is one of the key ingredients of semiconductors. That means options B and C are incorrect. Now, whether it is a P-type semiconductor or an N-type semiconductor depends on what is added. If you know your periodic table, you know that silicon has atomic number 14. So that means it's got 14 protons and 14 electrons in an atom. Phosphorus has atomic number 15, which means it's got 15 protons and 15 electrons. Now, if you notice, electrons of phosphorus are more than electrons of silicon. So when you add a minute quantity of phosphorus to a silicon crystal, you're adding one extra electron, which then starts displacing the lattice of electrons in silicon, which means that it becomes more negative, whether partially or not. So it becomes partially negative, and that makes it an N-type semiconductor. So option A turns out to be the right option. A P-type semiconductor is created when elements such as aluminum are added to a silicon crystal. Now, since they have lesser electrons than silicon, they create a positive hole to which one of the electrons of silicon can bind itself, which then leaves a hole in the lattice of silicon. So option A turns out to be the right option for this question. Next question. Photons of energy 6 electron volts fall on the surface of a metal with a work function of 4 electron volts. We need to find the stopping potential of the metal surface. So, how do we solve this question? For that, we will need to find out the maximum kinetic energy of ejected electrons in electron volts. So the maximum kinetic energy, that is Ke, is equal to the incident energy of the electron minus the threshold energy of the surface, which in this case is the work function. So therefore it will be 6 electron volts minus 4 electron volts, which equals to 2 electron volts. So the maximum kinetic energy of ejected electrons is 2 electron volts. However, we know that energy in electricity is equal to charge times voltage, which is the same thing as potential. So we know that the energy we have is 2 electron volts. The charge would be the charge of the electron, which we can represent as E, and voltage can be represented as V. So from this expression, we can find V equals 2 electron volts divided by E. We can cancel both of the E's because both E's stand for charge of an electron. So therefore, the stopping potential at the end turns out to be option A, 2 volts. So we're going to use the formula for maximum kinetic energy of ejected electrons and also the formula for energy, which is charge times voltage. So according to those, option A, 2 volts turns out to be the right answer for this question. Now let's look at some questions from chemistry. Which one of the following acts as an antihistamine? Is it equinol, morphine, serotonin, or bromophenylamine? So, let's look at the properties of each of the options. Starting from A, equinol. Equinol is classified as a meprobamate, and it is used as a sedative, which means it is used for tension issues and also for the nervous system. And it's got side effects. So option A turns out to be incorrect because we're talking about a sedative that is equinol, which is not an antihistamine. Option B, morphine. Morphine is what we call a painkiller, which means it's called an analgesic. And when morphine is treated in a certain process, it can be turned into heroin, which makes it a narcotic. So therefore, option B again is incorrect. Option C is serotonin. Serotonin is actually a hormone found in the body, which its main function is to communicate messages between nerves. So from one nerve to another, from one synapse to the dendrites, um, chemicals are used to communicate, and one of the chemicals that we use in our body is serotonin. So since serotonin is a hormone inside the body, it's not used as an antihistamine. So option C is incorrect. The right answer is option D, bromophenylamine. And since it's an antihistamine, it's used for conditions such as wheezing and a runny nose. Moving on to our next question. Sodium dodecyl benzene sulfonate refers to anionic detergent, soap, cationic detergent, non-ionic detergent. So we're dealing with a chemical called sodium dodecyl benzene sulfonate. Now this here is it's used to clean tableware and fruits. And some properties that it has are it's difficult to volatilize, it's easy to dissolve in water, and it has stable hard water properties in acid and alkali. Okay, so well, these don't help us understand whether it's an anionic detergent, a soap, a cationic detergent, or a non-ionic detergent. However, if you look at them closely, we see that it's got stable hard water properties. Now, soap does not work in hard water, so option B turns out to be incorrect. So we are dealing with a detergent, we just don't know whether it's anionic, cationic, or non-ionic. So in order to better understand what we're dealing with, let's draw the structure of a dodecyl benzene sulfonate. So dodecyl means 12. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 connected to a benzene ring, and since it's sulfonate, that means it would have a sulfur atom connected to 3 oxygen atoms. Now if you notice, Sulfur's valence electrons are 6. That means it can form 6 bonds. And it usually forms double bonds with oxygen. So with 2 oxygens already added, it's got 4 bonds, and sulfur is connected to the benzene, which means it's got 5 bonds. However, it can only form one more bond with the third oxygen. Now that means it has a negative charge. Oxygen usually has a negative charge of -2, and since one of its electrons is bonded in a covalent bond, the remaining charge is -1. So as you can see, there is a negative charge, which means it is anionic. So therefore, option A, anionic detergent, is the right answer. A non-ionic detergent would have no charge, and a cationic detergent would have a positive charge. So both of those options are incorrect for this particular question. Now let's look at some questions from mathematics. The straight line 3x plus 4y plus 4 equals 0 is moved parallel so that its distance from the point 3, -2 is increased by 4 units. We need to find out its equation in the new position. And we have 4 options given to us. In order to solve this question, we need to find out the distance of the point 3, -2 from the straight line 3x plus 4y plus 4 equals 0. Now, the formula for distance in this particular scenario is ax1 plus by1 plus c divided by the under root of a squared plus b squared, and all of this is kept under a modulus. Now, a, b, c stands for the coefficients and the constant in the straight line. So let's substitute those values. A stands for 3, x1 stands for 3 again, b stands for 4, y1 stands for -2, and c stands for 4. Divided by 3 squared plus 4 squared. Now all of this is kept under a modulus at all times. 3 times 3 is 9, 4 times -2 is -8, plus 4. Divided by 3 squared is 9, plus 4 squared is 16. That is kept under a root. So 9 minus 8 is 1, 1 plus 4 is 5 at the top, and at the bottom it's 9 plus 16 gives us 25, so 5 divided by under root of 25 is what we get. Now under root of 25 is still 5, 5 upon 5, modulus. So that means the total distance between the point 3, -2 and 3x plus 4y plus 4 equals 0 is 1 unit. Now, according to the question, the distance between the point and the line is increased by 4 units, which means the new distance is equal to 1 plus 4, that is 5 units. However, the distance is increased by 4 units because the line is moved parallelly. Now that means A and B are the same, however, C is different. So the new distance would be 3 over 3 plus 4 over -2 plus, instead of the old C, which was 4, we're going to add something called C new in order to represent what we should be getting. So basically we need to find the equation in the new position, and for that we need to find out C. If you look at the options, you can see that all of them have the same coefficients for x and y. It's the constant that changes. We need to find the constant first, and by finding the constant, we can find out what the equation is. C nu divided by 3 squared plus 4 squared under root. All of that is kept under a modulus. So on the left side we have 5, and on the right side, let's just 3 times 3 is 9, 4 times minus 2 is minus 8, 9 minus 8 gives us 1. So 1 plus c nu over 3 squared plus 4 squared, that's 9 plus 16, that's under root of 25, which is still 5. And let's try to remove the modulus so it stays positive. So 1 plus c nu would be 25, 5 times over 5, 5 times 5. So c nu would be 25 minus 1, which is 24. So now we know that the constant is 24. And it's plus 24. So therefore, the correct option for this question would be option D, 3x plus 4y plus 24 equals 0. So that's how we solve this question. We find out the distance that the point and the line have. Then we use the question's assumption that the distance is increased by 4 units by moving the line in parallel, which means we have the same coefficients but a different constant, which means we find the constant using the same distance formula, and then finally we get c nu, that is the new constant, and we just apply that to the old equation. Now let's look at the final question for this particular episode. The equation of the line mid-parallel to the two lines 5x minus 2y minus 9 equals 0 and 5x minus 2y plus 7 equals 0 is. So in order to understand the question, we've got two lines. The first line is 5x minus 2y minus 9 equals 0, and the second line is 5x minus 2y plus 7 equals 0. Now we've got a third line. Now the thing about this line is it's at the middle of the two lines, and it's parallel to the two lines. Okay? Now, we're not interested if it's in the middle or if it's to the sides. What we are interested in is the fact that it's parallel. Now, if a line is parallel to any other line, it means that its x and y coefficients are the same. What changes is the constant. Now that means our new line, the equation of the line we're looking for, must have 5x minus 2y plus whatever the constant would be equals 0. So this is how our new line should look like. Now let's look at the options. The first option says x plus 5y. The coefficients are completely different. Option B is 5x minus y. Again, coefficients are completely different. Option C, 2x minus 5y, completely different. Option D is 5x minus 2y minus 1 equals 0. It's got the same coefficients. That means option D is the right answer. Now, why do we say that x and y coefficients have to be the same? Because the slope of this line is negative of a by b, where a is the x coefficient and b is the y coefficient. Now I seem to have made some mistake here. Let's just correct that. So negative of a over b, where a is the x coefficient and b is the y coefficient. Now the x coefficient is plus 5 and the y coefficient is minus 2. So this is what the slope should look like, and therefore the only option that correlates with that has the same slope is option D, 5x minus 2 y minus 1 equals 0. So therefore, since it should have the same slope, that means it should have the same x and y coefficients. So option D turns out to be the right option. Now that concludes this episode of AEEE Training. We hope you found this episode interesting and informative. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. You can also click the bell icon present below the video to get the latest updates from our channel. So until the next webisode, take care, stay alert, bye bye for now.